In the lush jungles of western Honduras, near the border with Guatemala, lies Copan, a city that was once a vibrant heart of the ancient Maya civilization. Over 1,000 years ago, its towering pyramids, intricately carved stone monuments, and bustling plazas echoed with the life of a thriving society. Yet around 1,200 years ago, Copan experienced a mysterious collapse, leaving behind ruins that have puzzled scholars for generations. What caused the downfall of Copan and the broader classic Maya civilization? Was it environmental catastrophe, social unrest, political instability, or a collision of cultures? A new study offers fresh insight through the analysis of ancient DNA. Researchers from Trinity College Dublin analyzed the DNA of several individuals buried during Copan's height. Their findings reveal new clues about the city's population makeup and, most importantly, the forces behind its eventual decline. Copan was no ordinary city. From roughly 250 to 950 AD, during what archaeologists call the Classic Maya period, it served as a major capital on the southeastern edge of the Maya world, a cultural crossroads linking Central and South America. Its story begins even earlier, in the early pre-classic period, before 1000 BC, when small farming communities settled the Copan Valley, relying heavily on maize. Maize was so central to Maya life that their creation myths describe humans as being formed from it. A turning point came in 426 AD with the founding of a royal dynasty by Kinich Yaks Kuk Mo, a charismatic outsider whose origins remain uncertain. Ancient inscriptions record his arrival in Copan in 427 AD, marking the beginning of a dynasty of 16 rulers who governed for nearly 4 centuries. Under their rule, Copan flourished as a center of art, astronomy, and long-distance trade. But by 820 AD, the political system collapsed, monument construction stopped, elite authority weakened, and the population declined. The new DNA study sheds light on this critical period. Researchers examined the remains of 7 individuals buried during the Classic period. Among them were 2 men whose burials tell strikingly different stories. One, known as CPM-13, was interred in an elaborate tomb near the Acropolis and surrounded by jade and fine pottery, clear signs of elite to a royal status. The other, CPM-12, was buried nearby in a position typical of ritual sacrifice, possibly meant to honor the gods or seal a political agreement. Both men shared a Y chromosome lineage known as Q1b, a paternal marker common among indigenous peoples of the Americas. Despite this shared lineage, they were not close relatives. The remaining 5 individuals, 3 women and 2 men, carried diverse mitochondrial DNA haplogroups, primarily A2 and C1. Because mitochondrial DNA is inherited through the maternal line, this diversity suggests that women from varied backgrounds were part of Copan's population. To place these findings in a broader context, the researchers compared the genomes to a wide dataset of ancient and modern DNA from Siberia and across the Americas. The results revealed remarkable continuity. The people of Copan were genetically linked to populations in the Maya region dating back to the late Archaic period, about 5600 to 3700 BC. This ancestral thread connects Copan's inhabitants to early populations in Belize, later Maya from Chichen Itza and Campeche, and even to the nearly 7 million Maya living today across Mexico, Guatemala, Belize, and Honduras. Yet Copan's story is not one of continuity alone. It is also a story of change. The DNA data reveals an influx of ancestry from highland Mexican populations, likely from regions such as Oaxaca, home to Zapotec peoples. This influence began during the early to middle Classic period, 250 to 550 AD, and became more pronounced in later Maya centers like Chichen Itza. At Copan, highland Mexican ancestry accounted for about 6% of the genetic makeup, suggesting that migrants, possibly elites within broader Maya networks,
integrated with the local population. This aligns with archaeological evidence of Copan's extensive political and trade connections with cities like Tikal and Teotihuacan. Isotopic studies of teeth and bones support this view, showing that many elites grew up outside Copan before settling there. Kinich Yaks Kukmo himself may have been one such outsider, founding a dynasty that blended local and foreign traditions. This fusion likely enriched Copan's culture, producing its extraordinary art and architecture, but it may also have introduced vulnerabilities during times of crisis. The DNA evidence also reveals patterns of population growth and decline. Using identical by descent analysis, which measures shared DNA segments to estimate population size, researchers found that Copan's population expanded significantly during the Classic period. By around 730 AD, the effective population size reached roughly 19,000, reflecting a large, thriving community supported by maize agriculture. But this growth came at a cost. Intensive farming placed enormous pressure on the Copan Valley's soils. Fields were pushed to their limits to sustain laborers, artisans, and elites alike. Genomic data indicates a sharp decline in population beginning around 750 AD, just decades before the political collapse. Agricultural strain was not the only factor. Severe droughts between the 9th and 11th centuries likely devastated maize harvests, intensifying food shortages. Political rivalries with powerful city-states such as Tikal and Calakmul added further instability. Social inequality may have deepened tensions as wealth concentrated among elites while commoners bore the burden of food production.
The contrast between the lavish tomb of CPM 13 and simpler burials elsewhere hints at a society increasingly divided. Beyond Copan, the study has broader implications. The Q1b Y chromosome lineage ties the Maya to the earliest migrations into the Americas via the Bering Land Bridge over 15,000 years ago. The mitochondrial haplogroups A2 and C1 form part of a continent-wide genetic legacy stretching from Alaska to Patagonia. While groundbreaking, the study is only a beginning. Larger sample sizes across Copan and other Maya sites may reveal regional and temporal differences. As ancient DNA techniques advance, future research could identify signs of drought stress, disease, and internal migration, offering even deeper insight into the Maya world. Thanks for watching. If you enjoyed this exploration, don't forget to like, subscribe, and leave a comment with your thoughts or questions. Until next time, keep exploring.